Welcome to CAD Tips in Education. Hi, my name is Marie Blanchard and I'm Director of World Education Markets here at Dassault Systems SolidWorks. Thank you for joining me today. I put together a series of CAD tips based upon my 10 years in the classroom. The first CAD tip we will discuss is part orientation. Can you actually teach visualization before orthographic projection? Let's take a look at this cylinder. I'm certain your students can recognize a cylinder, but whether that cylinder is positioned at the top plane, the front plane, or the right plane changes its orientation. Let's take a look how you can teach this very important concept in SolidWorks.
With any model in SolidWorks, you can use the View Orientation menu to look at a model from the front, from the top, from the right, or you can look at the relationship in 4 views, top, front, right, and a trimetric. Usually in SolidWorks, we work with one view, using the mouse to rotate, pan, and zoom. A new student can understand the general shape of a cylinder. Let's take a look at this part from the gripper assembly. It certainly is cylindrical shaped. How would you create this in SolidWorks? Traditionally, you may have used orthographic projection, but we would like you to introduce students to visualization and orientation right in 3D. Let's start with a part. Select on Part, right-click on the right plane, and select Sketch. This opens up a sketch on the right plane. Click Circle. Select the origin, drag outward to the right. Right-click Smart Dimension. Select the circumference of the circle, click a position outward, and enter a dimension. The black sketch is fully defined. Select on Features. Select Extrude Boss Base. You can select the direction vector outward a specific distance as indicated by the ruler. You can also extrude in 2 directions. You can use midplane to build symmetry. Let's take a look at how the planes act inside this cylinder created on the right plane. Click OK to complete the feature. A student can certainly recognize a cylinder on the right plane, but understanding multiple planes is important. Right-click on the sketch, select Edit Sketch Plane. Now select the top plane. Click OK. The top plane is now your sketch plane, and the circle has moved to the top plane and extruded in 2 directions, symmetrical about the top plane. Right-click on the sketch again. Select Edit Sketch Plane. Now you can switch the top plane to the front plane. Click OK. The circle is now sketched on the front plane and extruded in both directions to create the feature. Notice the planes, front, top, and right. This is a simple exercise to show your students part visualization and plane orientation in space.
CAD tip number 2. Remember these 3 simple steps: plane, sketch, feature. Let's take a look on using the plane, sketch, and feature in SolidWorks.
When you first start teaching SolidWorks, give your students 3 simple rules: plane, sketch, feature. Right-click on the plane, click Sketch. Select a sketch tool from the sketch toolbar. You can start out with the center rectangle. This teaches symmetry with 2 intersecting diagonal construction lines. Sometimes students continue to sketch with the rectangle tool or other tools they have. Remember, undo is only a click away from the top menu. Sometimes, too, students will create very small sketches. They don't realize that on the toolbar is the rectangle or other sketch tool. Select on Smart Dimension. Click the horizontal line and enter a dimension. Be certain to position your dimensions off of the sketch. Right-click Select in the Graphics window to Window Select Geometry. A right-to-left crossing window will select anything that window attaches to. A left-to-right crossing window will only select objects that are fully enclosed in the window. You can select multiple entities with the Control key. In this case, select Equal to make the horizontal and vertical lines equal. There are other options in the Add Relations box. Select on Features. Select Extrude Boss Base. In the Boss Extrude Property Manager, there are many options to explore. Your students should feel free to experiment with the Thin feature, or to cap the ends of the feature. To add draft to extrude in 2 directions, there are many options. Sometimes students exit the sketch without creating the feature. The sketch will appear on the Feature Manager. It's okay. All you have to do is select on the sketch and then select the correct feature from the Features toolbar. You can use the direction vector and say OK. There are many ways to create a feature in SolidWorks. Let's try a different way that your students might experiment with. Select on Part. First select Extrude Boss Base. The 3 planes top, front, right will be displayed. You can select any one of these planes to determine your sketch plane. Now create your sketch. Again, build in as much symmetry to the sketch as possible. When in doubt, right-click in the graphics window. The odds are the command that you need will show up in the pop-up toolbar. Also, you will get tool tips if you just hover your mouse pointer over a particular tool. For this rectangle, control the width and the length with different dimensions. Select Exit Sketch to complete the Extrude Boss Base feature. The green check mark completes the feature.
CAD tip number 3. Let's talk about using symmetry in both the sketch and feature. Your students can look at this simple plane and realize that it is symmetrical about a plane. I love teaching symmetry because students can really recognize the importance of symmetry in SolidWorks.
You want to incorporate as much symmetry as you can into a feature and the sketch. Open a part. Let's take a look at this part. We have a circular pattern of an extrusion. Let's create the first seed feature of the pattern on the right plane. Using the rollback bar, drag the bar in the Feature Manager to see how this extrude feature was created. The feature is symmetric about the right plane. From the top view, I can see the right plane cut right through the feature. Let's take a look at the circle. This was the first feature in the part. Notice how the right plane cuts right through the circle and is coincident with the origin. Right-click on the sketch to edit a sketch. Let's take a look at this sketch on the right plane. Notice the sketch is fully defined and displayed in black. The dimensions indicate the shape of the sketch. The dimensions are clear and displayed off of the profile. Right-click on the feature and select Edit Feature. Here you can see that midplane was used as the direction option. From the right plane, the feature is extruded in 2 directions. Fillets are added, and now let's take a look at the cut feature. How was this created? Right-click on the sketch, click Edit Sketch. Let's take a look at the rectangle. Again, the rectangle is aligned with the origin on the right plane. There is a midpoint on the right plane, and a dimension is added to complete the cut.
CAD tip number 4, relations. You want to insert geometric relations, then add dimensions. I love these tips because they involve my favorite subject, geometry. Let's see.
Your students can practice their geometry skills with geometric relations. It is a good practice in 3D modeling to create relationships before dimensions. Let's begin a new part and sketch on the front plane. Right-click on the front plane, click Sketch. This time, we'll use Straight Slot, the center point option for a straight slot. Select the origin. Drag outward and to the right. Now click a point and then select upward to create the radius of the slot. The mouse pointer picks up inferencing, vertical and horizontal. Sketch 2 small circles at the endpoints of the center line of the slot. Right-click, select. Select the first circle, hold the Control key down, select the second circle, click Make Equal. Now the two circles are the same diameter. There are other options in Add Relations, such as concentric. Sketch another circle out in the graphics window. Right-click, select. Select the large circle, hold the Control key down, and select the small circle. Select Make Concentric. Now the two circles are concentric. You can also select other options like tangent or co-radial. The options that are presented to you in SolidWorks depends upon the geometry you select. Select Smart Dimension and enter a dimension. Continue to dimension the other geometry in the sketch. Radial dimensions contain an R in front of the dimension. Diameter dimensions can be displayed linearly with the diameter symbol in front of the linear overall dimension. Select Features. Select Extruded Boss Base. Now, using selected contours, I can select different areas of the geometry to extrude. As I select each piece, it is extruded by a certain depth. Click OK to complete the base extrude.
CAD tip number 5, reference geometry. You get a lot of mileage in SolidWorks if you can insert planes, coordinate systems, points, and axes for a part. Let's see how reference geometry can help you and your students in SolidWorks.
Reference geometry plays an important role in modeling. Click the top plane. Hold the Control key down and drag upward to create multiple planes. You can enter a distance between the planes and the number of planes you want to create. Click OK from the Plane Property Manager. There is a sketch created on the top plane. Click the sketch. Press Ctrl+C to copy the sketch to the clipboard. Click Plane 1. Press Ctrl+V to paste the sketch. Now edit the sketch. Right-click on Sketch 2 and select Edit. You can modify the dimensions. Exit the sketch. Select Loft Boss Base. Select the bottom sketch. Select the second sketch. Now you've created a loft feature. Select the top face of the loft. Right-click Sketch. Sketch a circle. Remember those relations. Right-click Select. Select the circle. Select the edge of the square. Select Make Tangent. Now the circle is tangent to the edge of the face. Select Extruded Boss Base. Select Up to Surface and use the second plane to create the feature. There is different types of reference geometry you can use. For planes, you can select a cylindrical face and add more control by selecting a second reference, such as a plane or edge. Now you can control the angle of the plane in rotation. For students studying dynamics, it is important to understand how to manipulate the coordinate system. By default, the origin is the coordinate system, but you can add different coordinate systems to your model. For example, select Reference Geometry and select Coordinate System. Click the intersection of where the coordinate system's vertex will be. Select a direction for X and a direction for Y. You can flip the direction of an axis to change the direction of the coordinate system. Now for mass properties, you need to change the coordinate system from default to coordinate system 1. Select Mass Properties from the Evaluate tab, select the down arrow, and select Coordinate System 1 to recalculate the mass properties.
CAD tip number 6, reference geometry in an assembly. You want to mate two axes and planes to control physical behavior in an assembly. When students are first learning how to insert components into SolidWorks, everything seems to be fixed in space. But in the case of this robot or any vehicle, it is important that the wheels are able to rotate. The easiest way to do that is to begin with reference geometry in the form of an axis. Then you can mate the wheel to the axis concentrically, and the wheel will rotate. Let's take a look at reference geometry in an assembly in SolidWorks.
Reference geometry also plays an important role in an assembly. Select Reference Geometry Axes. When you are creating frames for vehicles such as robots or small cars, you want to create axes for wheels. An axis can be created between two planes, such as the top plane and the front plane. Once the axis is complete, you can then insert components. When a part is inserted into an assembly, it is called a component. You can browse for multiple components on your desktop or use 3D Content Central. Position the wheel in the assembly window. The wheel is the first component in the assembly, and it is fixed by default. In order to mate the wheel concentrically to the axes, I'll have to float the component. Right-click on the component, click Float. Now select the cylindrical face of the wheel, hold the Control key down, select the axes, click Mate. Coincident is selected by default, but you want concentric. Select concentric, click OK. Now the wheel moves concentrically about the axes. We need an additional mate to place the wheel. Let's select the right plane. When you select the right plane, you then want to select a plane of the wheel. Now normally, you would have created this wheel symmetric about a plane, but this wheel was created in one direction. So we're going to build a symmetric mate. By using a symmetric mate in the Advanced Mate section of SolidWorks, you can select on two faces and a symmetry plane. Select the symmetry plane, and now the wheel becomes symmetrical about the right plane of the assembly between its two flat faces. Let's see how the wheel rotates. I'll unsuppress a small cut in the wheel. And now I have the perfect physical behavior for the wheel in my assembly.
CAD tip number 7, reorient components. When students first start out modeling, they may orient a part in a direction not used in the assembly. For example, take this cap. The student may design the cap with the opening on the front plane. But once it's placed into the assembly, the cap is to be positioned on top of the bottle. In SolidWorks, students can use Rotate Component and reposition the component with planes. Also important to realize in an assembly, especially you as their teacher, you want to get the complete assembly. The File Pack and Go option is a great way to zip all the parts and assemblies together and send it to you electronically, saving paper and making sure you get all the components. Let's take a look at CAD tip number 7, Reorient components in the assembly.
When students are first learning SolidWorks, they create parts. When parts are brought into an assembly, the orientation of that part might not be the desired position. You can modify the orientation of any component in an assembly, and it's best to do that right from the beginning. Right-click on the fixed component in the Feature Manager and select Float. Underneath Move Component, select the drop-down arrow. Select Rotate Component. Now you can modify the position by Delta XYZ. Select the component to rotate, enter an angle, and then click Apply. The component rotates 90 degrees about the x-axis. The component is still free to translate and rotate as indicated by a minus sign. Students need to recognize the F for fixed and the minus sign for underdefined. You can add plane relationships to mate the component and fix geometry. In this case, I will select the front plane and the back surface of my L bracket. Click Mate. Coincident is selected by default. Click OK. Select the top plane of the assembly. Select the inside face of the L bracket. You can use right-click Select Other to get the bottom face of the L bracket without rotating the component. Select Other toggles through different geometry in the path of the mouse. We need one more mate. Select the right plane, select the right surface. Coincident is selected by default. Click the green check mark. Click OK from the Mate Property Manager. There is no minus sign in front of the first component of the assembly. This indicates that the component will not translate or rotate and is referenced to 3 planes in the assembly.
CAD tip number 8, Drawing Template. You can create a custom drawing template containing your school logo, units, projection type, and your school name. This will save your students lots of time and make their drawings look professional. Also, you can utilize e-drawings for easy grading without using paper. E-drawings is a great way to mark up what your students have done wrong or right and get new iterations of the drawing. Let's begin and see CAD tip number 8, Drawing Template.
A drawing consists of a drawing template and a sheet format. Right-click on any new drawing. Select Edit Sheet Format. Now, the sheet format can be edited, such as a student can enter their name, your school name, or even a school logo. By working with the title block to make certain it contains the right units, type of projection, part numbers, class information, the title block contained in the sheet format can be utilized by students over and over again. Click Options from the top menu. Select Document Properties Units. In this case, I selected millimeters as my unit. Right-click Properties. Change the projection, if required, from first angle to third angle. Select File, Save Sheet Format. Click Yes to replace the existing sheet format or enter a new sheet format name. Select File, Save As. From the drop-down arrow, select Drawing Templates. The drawing template is the foundation of the drawing. It indicates the size, units, and type of projection. Expand the View palette and select on a part. The views are displayed. Click and drag the views into the sheet. You can modify, scale, and display. For example, select the isometric view, click Shaded, click Use Custom Scale, and enter 1 to 2. Reposition views in the sheet by clicking on the view boundary and dragging. Students should position all views before they insert dimensions. E-drawings is a great way to save on paper in your classroom. Students can create an e-drawing and submit for a grade. E-drawings can contain assembly information and drawing information such as bill of materials and dimensions. You can mark up an e-drawing and resubmit comments back to your students.
CAD tip number 9, SolidWorks Tutorials. I can't begin enough to tell you about the SolidWorks tutorials that are available in Help, SolidWorks Tutorials. Here, over 40 tutorials exist in all languages of our products to begin part modeling, assembly, and drawing. Also, there are advanced modeling techniques in weldments, sustainability, sheet metal design, piping, and electric routing. Inside of Tools Add-ins are the SolidWorks simulation functions, including Finite Element Analysis, FEA, SolidWorks Motion for kinematics, and SolidWorks Flow Simulation for computational fluid dynamics. Once these add-ins have been turned on, underneath Help, SolidWorks Simulation Tutorials are hundreds of tutorials for you to take a look at. We realize that these concepts may be a bit complicated for students, and it's important to visually see how finite element analysis with these simulations can show physical conditions. Let's take a look at CAD tip number 9, SolidWorks Tutorials.
SolidWorks contains hundreds of tutorials in SolidWorks and SolidWorks Simulation. To begin, create a new part. From the Help menu, select on Help, select SolidWorks Tutorials, and select one of the many SolidWorks tutorials that are available. You can view a small preview by positioning your mouse pointer over a particular tutorial. There are 2 columns of tutorials. You can see them all at once or one at a time. Each of the tutorials represents different technology inside of SolidWorks. Our recommendation here at SolidWorks is to begin with Lesson 1 parts. Each lesson contains step-by-step instruction. You can expand to get more instruction. In the Evaluate tab, in the SolidWorks Education Edition, live SolidWorks Simulation, our FEA tools, and SolidWorks Motion. Underneath Tools Add-ins, you will see SolidWorks Flow Simulation. You need to turn on the simulation products in order to view the simulation tutorials. The SolidWorks simulation tutorials consist of static nonlinear frequency fatigue, drop test, linear dynamics, and design studies. Inside of design studies are shape optimization, parameters to evaluate the design, and design optimization. Also, inside of SolidWorks Simulation is a series of validation tutorials. The validation tutorials compare SolidWorks analytical results with theoretical values. This is important as engineering students are learning concepts in statics, dynamics, machine design, thermal heat transfer, fluids, and vibrations. Also under validation is the NAFEMS benchmarks. The NAFEMS benchmarks is an organization that determines finite element analysis benchmarks. Here you have examples in static, thermal, linear, nonlinear analysis. Also under SolidWorks Simulation, is the Flow Simulation Tutorials. The Flow Simulation Tutorials step you through different types of flow analyses in designing a ball valve to cooling a CPU unit. Try out some of these for fun.
CAD tip number 10, Educator Resources. The SolidWorks Education team is behind you in the classroom. Besides the SolidWorks tutorials that you saw in CAD tip number 9, we also provide a free model library, www.3dcontentcentral.com. Years ago, when I was first involved as an educator with SolidWorks, I heard former President John McElhaney say, "If you have to make a model and it already exists on 3D Content Central, you're wasting your company's time." Students need to know how to learn standard components at 3dcontentcentral.com. We also provide additional curriculum at the customer portal. You need your serial number and are required to create your own login. There are free tutorials available at solidworks.com/SolidWorks Tutorials. If your students are visual learners, these videos will be priceless. The teacher blog has been around for 6 years. I am happy to report on stories from around the world at the SolidWorks teacher blog and share with you other models that professors and instructors have created. The SolidWorks forum is great for both students and educators and provides a great resource to ask questions to our SolidWorks community. The SolidWorks user group is available throughout the world with 200 plus organizations. If there's not one at your school, you can start one. The SolidWorks blog is also available at blogs.solidworks.com, featuring a host of commercial users that just talk about modeling. It's great. We also have videos on YouTube, and you can find many of our customers and examples through Google search. The value-added reseller in your community is there to support you in the installation of SolidWorks and your training. Let's take a look at the CAD tips number 10, Educator Resources.
SolidWorks has many resources for educators and students. First, 3D Content Central contains 2D and 3D models, assemblies from suppliers, industry-recognized components in air cylinders, motors, switches, a variety. There are also components from our customers in the user content area. For example, enter in FSAE and see components that have been added by leading suppliers and also students from around the world. Your students don't have to begin from scratch. If a model exists, use it. Here, I look for robotics components under the manufacturer VEX. There are controllers, wheels, and switches that belong to the VEX robotic system. Also for educators is the customer portal. With your SolidWorks serial number, you can log into the customer portal and find Educator Resources. Inside of Educator Resources, there's the Instructor's Guide and Student Guide to Teaching SolidWorks in many languages, Sustainability Project, Simulation Project, Motion Project, SAE Car Project, Bridge Design Project, CO2 Car Project, F1 in Schools, Mountain Board, Hands-on Test Drive, SolidWorks Simulation Hands-on Test Drive, a Trebuchet Design Project, Robot Models for Lego, VEX, and Pitsco, SolidWorks Tutorials for Technical Vocational School, Actual Manual Drawings, a Windmill Project that charges a cell phone, and small Lego assemblies. The SolidWorks Tutorials page contains great videos on how to learn SolidWorks with additional projects for your students. You can download worksheets and tutorial assignments, all using the internet. As students watch the videos, they pick up on great tips. There are 5 lessons in getting started that cover parts, assemblies, drawings, simulation, and sustainability. The SolidWorks Teacher blog is filled with weekly exercises that expand your knowledge and your students' knowledge about using SolidWorks. Great tips from other educators and students are posted on the teacher blog. Some of them are pretty fun, like this turtle in flow analysis. Also, accessible to you and your students is the SolidWorks forum. There's a special area for educators and students to ask questions to the millions of users that use SolidWorks every day. The forums is a great resource for information. The SolidWorks User Group Network is a great community of over 200 user groups throughout the world. It is the largest in the 3D CAD world, this community of user groups that meet quarterly. If you don't have a user group in your area, you can start one. I was fortunate to start a user group at my school. SolidWorks also contains videos on YouTube. Students can access YouTube and see great technique in using SolidWorks.
Thank you for watching CAD Tips and enjoy using SolidWorks.